Alright everybody, welcome back. In this video we're going to start looking at some properties of definite integrals that exist that we can use to manipulate definite integrals when we encounter them. Our whole discussion of these properties is going to rely on the fact that we consider the definite integral of a positive function to be an area accumulator. And so let's take a look at what that means and the implications that we have based off of that. Our first property here deals with order of integration. And the property says that the integral from b to a of f of x dx is equal to the opposite of the integral from a to b of f of x dx. And so suppose I have some function f of x that's strictly positive and continuous, although my stylus was not being particularly friendly with allowing me to show that. And I have endpoints for a definite integral at a and b. Okay? Now, the integral from a to b of this function can be found by just accumulating all of the area from left to right. So it's picking up all that area as I move from left to right across this region. Okay? And so the integral from a to b is going to be positive as we move, because we're moving from left to right. If I use this same function and instead accumulated the area in this direction, since we're accumulating area from right to left, it is instead going to accumulate that as negative area when we move from right to left. Now the amount of area that's accumulated in both cases is the same. However, when we accumulate it from left to right, it's going to be positive. When we accumulate it from right to left, it's going to be negative. And so those values are the same, but they differ only by a negative sign. And so the integral from b to a of this function is going to be equal to the opposite of the integral from a to b of this function. That's our first property. So anytime we have limits of integration where the lower limit of integration is a bigger number than the upper limit of integration, we can switch those limits of integration by simply putting a negative sign out in front of the integrand. All right, that's our first property. Property 2. The zero property for definite integrals. If I have a function f of x, in this property we're finding the integral from a to a. So we think about this, and a doesn't move, and so the amount of area that's accumulated as I go from a to a, well, I haven't moved at all. And so no area is accumulated as I move from a to a, and therefore the integral from a to a of any function is 0. And so anytime you would see a definite integral, like the integral from 2 to 2 of some function, since there's no motion, there's no area accumulation, and the value of this integral would just be 0. Okay? Continuing on. Our third property. Constant multiple property. So suppose we have a function f of x. And we would integrate it from a to b. Now suppose we take some constant k and multiply it times that integral. Like maybe we will just... this is really difficult for me. Come on. Maybe we will just double all the values of this function. I'm just going to put a few in to help guide me with the contour here. It's going to look something like this if we were to double f of x. Now what's happening here, if you think about how we found these areas to begin with, what we did was we would put little rectangles underneath this curve. And the only difference between the rectangles for the first curve and the second curve, their widths remain the same, but since the value of the function is always twice as tall, the heights of the rectangles are twice as large. And so when we calculate the areas of those rectangles, all we're doing is we're multiplying the heights of the rectangles by whatever this constant k would be. And so what we have here is we have the integral of the purple function, k times f of x, and all that's equal to is whatever the multiplier was times the original area that we have. In this case, since I used f of x and 2f of x, it's just going to double the value of that integral, since every rectangle is going to have the same width, but double the height. Okay? We have a special case for property 3 here, when we have the opposite of the function. So what we have here is we have f of x from a to b, and if we multiply this function by -1, see how well I do with this. Not great, but good enough. The integral from a to b of f of x accumulates all this area here, and the integral from a to b of the opposite of f of x accumulates all this area here, but that area is below the axis, so it counts it as negative value. It's the same amount of area, it's just an opposite sign. And so the integral from a to b of negative f of x is the same as the integral from a to b of f of x multiplied just by that negative. Alright, let's see. I think we can get through one more property. The sum and difference rules for integrals. The integral from a to b of f of x plus g of x is equal to the integral of f of x plus the integral of g of x. And the integral of f of x minus g of x is equal to the integral of f of x minus the integral of g of x. And again, this goes back to the same kind of idea that we used with the constant multiple. If we have a function, f of x, on the integral from a to b, come on, and we have a function, g of x, on the integral from a to b, if we take these two functions and add them together, all we're going to do is take their values at various points and add them together, and I'm just going to use a very short piece here. So a rectangle that I put underneath f of x plus g of x has the same width as the rectangles for f of x and g of x, but its height is just the sum of their respective heights. Same thing with the difference. And so I can split the integral from a to b of f of x plus g of x into the integral from a to b of f of x plus the integral from a to b of g of x, and just add their individual areas together, because when I add functions, all I'm doing is adding their individual values at their respective points. Okay? That's where we're going to close for now on properties. We'll come back next time in the next video and look at properties 5 through 7 from this lesson. See you guys next time. Have a great rest of your day.